Hi everybody, my name is Stefano Gridelli and I'm the co-founder and CEO of NetBeez. We're really excited to be here today after so much time, after so much development to show you the product. The agenda for this morning, we're going to start with a quick introduction about the company, the product, and why we decided to work on NetBeez. And in the second part of this session, we will, Panos, will show the features and the components of the NetBeez solution. And in the third part, we're going to go through a live demo of our network monitoring solution. So if you don't know what NetBeez is, we do network monitoring from the user perspective. And why from the user perspective? Because generally users know better than IT about the status of the network and of the applications. Right? So our strategy is simulate in a simple way with small hardware agents or virtual agents, users in the network, so we can have prompt detection of network outages. So let's start with a disease that affects many network engineers nowadays, network blindness. And it's a problem that happens when you don't know what is the status, the connectivity status of your users at your dozens of hundreds of network locations. You don't know the status of the services that you deliver and offer your users or the performance of the applications that they access every day. For us, network engineer, of course, is not really an easy job to provide a prompt response and outage detection. It's like driving in the fog, right? So when that happens, to get from point A to point B is much more difficult because you don't see the road ahead. So getting to the destination and finding the solution of a problem or what the problem is takes more time, like driving in the fog, right? So this is something that I'm sure it happened for you many times. It happened for me many times as a network engineer, that working on an outage, on a problem, and most of the time was spent also in collecting information about the outage, about the scale of the problem, what are the users affected, and how often this problem happens, right? So if we look at the network monitoring stack, right, there are network monitoring tools that are supposed to provide the information about the status of the network, right? And if we go on the network infrastructure layer, we have SNMP-based network monitoring and network management tools, right? These tools provide information about the status of the network equipment that compose the infrastructure, bytes in and out, right? CPU, memory usage of our routers, switches, wireless controllers. So those solutions are great, again, to know the status of the devices, but they can tell us so much. They don't give us too much end-to-end performance measurement. We don't know if the network as a system overall can deliver the application and services that we offer every day to our users, right? So if we go a little up in the stack, there is then the application layer, and we find here flow-based performance monitoring tools, right? These tools now, there are many great tools that provide NetFlow data or packet capture, right, or use taps. This tool, the problem is that they don't scale very well. They're generally installed in a centralized network location at the data center because taps are really expensive. Right? If you have hundreds of locations, it's difficult to deploy one tap for each network location. You can use NetFlow. So they're a great tool to basically troubleshoot in reactive way performance issues, right? And go down to the bit level within the packet and understand what's happening in your network and on the application layer. However, they're still limited. For example, they are passive, right? They don't provide you 24/7 information because if there are no users in your network infrastructure using the application, you don't have data, right? So if we go up in the layer, there are the users and the services, right? Users are our customer, the people that need to use, right, your network services, either is a guest internet access, right? Whether it's a cloud application, an application hosted in the data center. So always more now we're seeing that the applications are moving from our desktop, right, to the cloud. So the number of applications that rely on the network has grown exponentially. Almost any application now is running on the cloud. So the network is part of the application stack. So flow data can do so much, and we need a little more active monitoring, right, active data, right, 24/7. So synthetic transaction against the applications and with network services from the user perspective, so we can know from all the network locations, can the users connect to this or that application? Is my network, right, delivering the services that it's supposed to be, right? And we've talked with many customers in the last 2 years working on NetBeez. Of course, we made sure it was not an isolated case, right? And many customers agree with us that they have SNMP network monitoring tools, they have flow performance monitoring tools, yet it's not enough. It's not enough to cover, hundreds of network locations, right? They want something more synthetic, active monitoring from every location that constantly provide that information. So that's why we decided to build NetBeez. And right now, if we see at how this problem is solved, right? So how can IT gather information from the user perspective, right, when they're working on outages, right? So for example, we still use a technology that is more than 100 years old, right, the phone. Generally, the end user call help desk and report the problem that they see. Again, they know better because they're the remote site, so they know what's happening out there, but they're not the best person to communicate information that we need to troubleshoot the problem, right? So then what happened? When a ticket is open at the help desk, you jump on a conference bridge sometime with end users and other engineers or application analysts, and you try to understand where the problem is, what you're looking at, gather information, right, to fix the problem. Another way to solve this issue is by using dedicated workstation, right? So many organizations, they deploy dedicated workstation at remote site where they can either RDP to test the applications, or they can run their own script, maybe in Python and in Perl. They can, in a simple way, maybe run ping commands, traceroute continuously, so they can have that continuous feedback from branches right across the network infrastructure. Or, of course, there is the traditional command line interface, right? That's when the network engineer jumps into the problem. We tell it to this or that route or switch, start doing show IP routes, ping, trace route, right? Collect as much information as you can to validate, check your routing table, check what, what the users can reach from this or that subnet. Again, these are ways that still work, but they poorly scale. It's not automated. The problem of, for example, command line interface is that when you take generally like a show IP route or a ping, you don't have the data when the problem was happening. So troubleshooting sporadic connectivity issues is extremely difficult because we don't have the data to basically understand what we're looking at, right? So when we started NetBeez, we had 3 simple requirements, right? We look at the market space. We saw that there were not solutions that were really doing distributed network monitoring, right? So use of small, right, agents that would continuously send active traffic on the network. And the first requirement of NetBeez was monitoring from the user perspective. So like an endpoint, like a client connected to the access layer that would simulate in a simple way users accessing this or that application, because at the end, users are just endpoint that send packet on the network. So that's what the agent was supposed to do. Second, it must be distributed and scalable, right? So when you have hundreds of network locations, you need a solution that is really scalable, so that can really support one agent potentially per network location, right? That simulate that aggregate group of users, right? That have to all go through the same pipes, right? And the third requirement was simple to use and install. That is like imperative for us to make a solution that is simple to use, simple to install, plug and play. And that's why initially we're working with the hardware agents, right? Because they're plug and play. You don't need a dedicated workstation. You can ship an agent where you don't have ESXi, a VMware environment, or a router that can run a virtual appliance. You just plug it on the access layer. You can also ask one of your users, right? Everybody can plug a PC and power a plug, and you're good to go, right? So now we have a solution that really can scale to hundreds of locations because you just plug it in and you're good to go. And also simple to use because I've seen it many times. You have this complex network monitoring solution that takes so much time to set them up and also to use them. I mean, some solution like 3-5 days of training, and then you forget, oh my gosh, I have this or that manual. So we want something where the end user can use it in 1 hour, even less, knows how to use the dashboard. Because that's the best way that an IT group, a network group can provide the best support to the end users is having accessible information about the network. Any questions here? Oh, good. Green light, great. So that's why we developed NetBeez, right? And NetBeez is a distributed network monitoring solution that monitors the network from the user perspective. So what you see here is our dashboard that runs on the central server. It's all based on HTML5, right?
So just to, because we care about this, so no Flash, no Java ever?
There are some Java, but it's all integrated. So it's all HTML5.
Okay, not on the UI, yeah.
Right. Yeah. It's all HTML5, so no JavaScript. Yeah. So it's exactly plug and play. You don't need to install any plugins, right? It runs on the common browser. And as you can see, each agent is represented with a thumbnail. Then in the demo and panels, we'll provide better information, right, about all the features. So the way we build NetBeez is in 3 layers. It's a layer architecture, right? On the top, there is the user interface, the dashboard, right? That is simple and intuitive. Again, it must be easy, like anybody can do it from the service desk operator to your CIO, right? If they want to see what's happening in the network. And it's multi-user and multi-role, right? So we have, for example, multiple users, and you can have administrator, read, write, and read only. And then again, Panos will talk more about the type of different access privileges for our dashboard. Then in the middle layer is the server, and that's really where NetBeez is the intelligence, right? The server is the agent's controller, right? Because of course it's a distributed network monitoring, but the server is like a controller that push test information tested to the agents, collect in real-time tests from the agents, and then store them in the database, and also process this information in real-time to generate alerts, right, statistics and analytics about the network, right? So really, the central server is all about NetBeez and where we put a lot of efforts in the development. On top, also the user interface. And then there is the agents layers, also called Beez, right? And actually, I'm happy to announce that we have a new agent to the family. We have also a wireless agent, right? So right now we have 4 offerings. We have a wired agent based on, it's an RJ45 10100, but we also have a gigabit Gigi agent, right? If you want to send more traffic on your network. Then we have, this is exactly the wireless agents with the AB, so it's dual mode agent, right? So you can monitor, then we'll see more, but SSID availability, signal strength, channel, bitrate, etc., etc. And we have an external agent, right? You can have an agent in Google Cloud or on Amazon Web Services. And then we have also a virtual agent in case you want to install an agent in your data center, ESXi environment. So bottom line, our concept, I'm sure you're getting it, we want to really put agents everywhere. We want to have a sensor wherever there is an enterprise network, virtual hardware, small branches, wireless, right? So you have all the data that you need now to really understand what's happening in your network 24/7, right? So unlimited data from the network. And then the data can be useful in many ways.
We might be jumping ahead a little bit here, but we had a question come in from Aaron Paxson over Twitter. Do you guys support multi-tenancy in your dashboard for?
Single tenant. So okay. For us, the main customer is enterprise, right? So one instance, one customer, right? And actually, thanks for asking. Like the central server can run on-premise or on the cloud, right? So if you want all your data on-premise, virtual appliance, right? If you want on the cloud, we send it on the cloud. So really flexible with the deployment of NetBeez. Any other question of the architecture? Of course, then we'll see more details. Good. Okay, so a little story about us. We're 2 years old, right? Pretty young company. We're from Pittsburgh with a Pittsburgh accent, as you can imagine, right?
I hear it.
Panos has even a stronger accent, yeah. So we co-founded the company 2 years ago. Panos is our CEO. He does the development on the agent. Panico, our CTO, right? And myself, I was a network engineer, and also another co-founder is Dan Snyder. So we're a mixed scale between CCNP, CCIE, and also PhD, right? We started at the Alpha Lab Startup Accelerator in January 2013. That was a 5-month program, at the end of which we had a beta ready for deployment. In the second half of 2013, we basically started a private beta deployment in companies around the Western Pennsylvania region area. That was good to get the first feedback, make sure we didn't break anything. The beauty is that really it's just other traffic that runs on your network, so it does not require any inline device if you think, right? So we cannot. It's really like vendor independent, right? Non-intrusive network monitoring application, because at the end, the agent is just another user in your network, right? So that's the beauty. December, we had our first sale, a little less than 12 months that the company started. That was good for us. And then in 2014, we started offering cloud trials. So right now, if someone wants to run a trial of NetBeez, we spin a dashboard on the cloud. We just send them 3 to 5 agents, right? You plug it in the network, and you're good to go. The agents call your instance, and you can do whatever you want from there. Then by October, we deployed more than 370 agents across different customers. So our average number of agents is pretty high per customer, as you can imagine. And actually, in December, we had a good news. We were selected to participate to InterruptNet. So we will be monitor the InterruptNet network from the user perspective, and we'll be also at the SDN lab. This year, we're happy to announce in February, right now, the wireless agents. That's require a lot of course, efforts for the developers. And in April will be InterruptNet, so most probably many of you will be there. So we're looking forward to maybe show you more about NetBeez. We'll have also more features to announce at Interrupt. We have investors from Carnegie Mellon University, right? Most of us are alumni from CMU, Carnegie Mellon University in Pittsburgh, and Innovation Work, which is a local seed stage fund in Pennsylvania. So the use cases. So how, of course, NetBeez is detection, but it's not just that. So here I want to show you how we learn from our customer, the way that they use NetBeez. So in the first big section, there is fault detection and isolation, right? So what NetBeez does well is detection. So we can understand quickly, right, if a problem is local or global, right? So when you're troubleshooting, looking at a problem, you want to understand is something related to a specific site, or is something that all the locations are seen. So the component, right, in the network could be a different one, right? Could be maybe the cloud service, right? It could be the host router, right? So for example, it was used in many instances to detect problems on cloud services. For example, this customer had a point of sale system, right? And it was on the cloud. So they were able to see from the NetBeez dashboard that all the stores were basically seeing the same problem. So they could quickly escalate the ticket with the cloud service provider, right? Instead of having to troubleshoot, waiting for calls from the users, and understanding maybe then with the telnet and CLI commands what was the problem, right? It would have been otherwise really difficult for them to collect the data to quickly pinpoint the problem and escalate it. Another way is the online catalog, right? Because we do also HTTP transactions, right? So we were able to pinpoint whether it was in the front end or on the back end with a simple get query or extended get query, right? We saw basically we do a trend line, of course, of a network and application layer performance. So we could see a spike in the extended get query with some parameters. And that way it was easy for the team to understand where was the problem in the back end and not on the network. As of course is always the network, right? The third one was a VPN connection at a remote site, right? This customer has an internet connection with commodity internet. On top they have a VPN tunnel, right? Traditional split tunnel. The 10 dot goes on the VPN tunnel, and the D4 route goes on the internet. So detecting performance from that perspective is extremely difficult. It's really difficult with SNMP or other tools. You just install an agent, click, that's it, and then you start measuring, the internet experience, cloud services, access back to the data center, and make sure that that VPN tunnel is up, right? Otherwise, it's really difficult to detect the type of failure with SNMP.
I might be jumping ahead here, but
yeah.
what type of synthetic transactions can you do?
Right, so ping, DNS, traceroute, and HTTP.
Okay.
Yeah. Then in the future, we'll add more tests, yeah.
So when you say in the future you'll have more tests, what type of ideas? What are you guys looking at?
Yeah, good point. So generic TCP test, right? And then we're looking to build a platform on top of which we can run any type of application you want.
Okay.
Right? So we're putting the grounds for a platform where you can run anything you want, bottom line, yeah.
Okay.
Sort of app store, yeah.
Yep.
So the second is network measurement. Of course, we provide analytics about the network layer and application layer, right? So for example, NetBeez was used to enforce SLA with internet service providers, right? That data is difficult to collect. So for example, they had an outage, and they were able to plot the outage with our data and show the ISP, say, hey, my network was up because the ping to the gateway was still good, right? But the ping to outside the destination, outside my office, was down. You see the red line. So they were able to enforce that. And we can also actually generate reports, as we will see later, right? And you can also cross-compare uptime across locations, right? In just a click. So the second use case is site-to-site bandwidth measurement. So each agent can run iPerf. So you can spin an iPerf, process with a click. And
quick question.
Yeah.
iPerf 2 or iPerf 3?
Both. Two. iPerf 2.
2?
Yeah. So we do TCP, UDP, multicast, and then DSCP values you can put. Yeah. So you can run iPerf from any agent to any agent, from any agent to an iPerf server, right? And then, of course, there are pros and cons of iPerf. We're aware. We can talk about that later. QoS validation with iPerf, right? You can set the DSCP mark, right? And see if your QoS policy gets, see the counters increase in your router, right?
So can an agent be a target for another agent?
Yes.
Get two-way?
Right. In both iPerf, ping, because ping, with ping and traceroute, you can, as destination, put any IPv4 address. And with iPerf, we don't keep the server always running, but it's ad hoc. So you click run iPerf, and they spin the client and the server, and they run the traffic. And then they close down.
Okay.
Right.
Because I could see the use for having an agent in multiple locations. Mm-hmm. Somebody calls up. I got jitter on my phone right now, and I'm talking to someone at this branch.
Right.
Spin something up to hit between them, and then check the QoS, and if I could mark it the way that a phone call would look, and
exactly.
All that.
You can select UDP with maybe 100 kilobit per second, EF. Right, DSCP, and see the data jitter. iPerf is data jitter, right? But still, it's a good starting point. Then in the future, we do G711, 729 stream, so to have a MOS core.
Yeah.
Okay. And that's exactly the use case. So it could be to verify, hey, I have bandwidth, right? Mm-hmm. From the user perspective, of course. Yeah.
Are you supporting both IPv4 and IPv6?
Not IPv6 right now, but it's in the plan, definitely.
Time frame, roughly?
We don't have it yet, but yeah, hopefully as soon as possible. We have a lot of features to implement, so we're trying to prioritize as much as we can. But you would like to see IPv6 in iPerf and generic tests?
Well, as we're going forward, we're seeing more of that as a deployment option. And if that aspect is invisible, then it minimizes the use case. So
exactly.
Because you can have different quite different behavior for v4 and v6.
You sure can.
Different transit paths and things. So.
Yeah, no, absolutely. No, IPv6 is there. It's in our plan.
Okay.
Fourth use case is network planning, because we have data and we can keep a lot of data. Active performance data is lightweight compared to flow data. So, for example, with 200 agents, we can store, and Panos will show you how, 200 agents, 3 years of historical data for 1 terabyte. So you can have, a good baseline for your network from 3 years ago to now. So that is really important when you're doing network planning. You want to see what are the network locations that underperform, how this upgrade improve your performance across the network, right? That is all available in NetBeez with the reports. Okay, so customers. So as a startup, we have customers. We have top-tier customers in healthcare, retail, and wireless. Specifically, with the wireless agents, we had a strong demand, especially from higher education, right? So, in some environments, even up to 80% of the users are wireless clients. So they really need the client perspective to monitor that infrastructure, because from a controller, they just see the controller side of the story, right? So they want to see, okay, I'm using this or that specific algorithm to adjust my, the power levels. I want to see what is the impact on the wireless clients. And that is difficult. You have to do it now with the site survey. So with the NetBeez wireless agent, they just plug it there, and then they can see what is the impact on the wireless clients.
I'm assuming there'll be a demo of this later, maybe?
Yes.
Okay.
Yeah,
I'm looking forward to seeing that.
Right. The first version of the wireless. So, but yeah, we plot all the data. Signal strength, signal quality, BSSID. I'm sorry.
Airtime.
Airtime, yes. Yeah. Connected since, right? For a long, yeah.
Okay.
We can show you the disconnection, when the disconnection happened, and receive and transmitted kilobit per second on your WLAN.
Okay.
Right. So of course, healthcare is going through a major disruption. There are major, healthcare systems that have many offices, physician offices, spread across a geographical area, so they need constant uptime. And retail is going through cloud point-of-sale systems, right, and a wireless in-store experience. So also for them, their wireless agents are really important.